So let us go through this factorization work. I would need to share it first. That one. All right, so we were on grouping in a manner of 2 by 2. So we went through this one last time. This one I've just completed. So hopefully you got the same answer here. And this one I changed the question last time, and hopefully you got that answer over there. Because then also I gave you these problems to do for homework, and that even more hopefully you did. And these are the solutions. So quickly go through and mark those. And the next one that we're going to be dealing with is indices. All right, so indices. Indices is a revision from our previous foundation course, but it is generally a section that people struggle with. So hopefully this is again just going to be a revision for you guys. So we can start with just having a look at the terminology. So you will see that this little number at the top is known as either your index or your exponent. It depends on what curriculum you're looking at, what textbooks you're looking at. So in Cambridge, they generally use the word index. I was taught the word exponent. So if you hear me using the word exponent, it is an index. It is always quite significantly smaller than the base over there. So please make sure that it is very clear that it is an index and not just a number next to it. So if we start with what happens when you have a 0 index. So any number with 0 index equals 1. But that any number refers to the base, and the base cannot be 0. So if you have 3 to the power of 0, it equals 1. Minus 2 to the power of 0, it equals 1. 2,345,678 to the power of 0 is 1. But you've got to be careful with negative numbers if there's brackets or not. If there's no brackets like this, the answer is not 1, because this minus 2 to the 0 means that the 2 is to the power of 0, and it is multiplied by negative 1. That is a different situation to negative 2 to the power of 0. So this means that the 2 to raise to the power of 0 is 1. 1 times minus 1 gives an answer of minus 1, not 1. And if your base is 0, 0 to the power of 0, this does not equal 1 either. The irony is that it may equal 1, it may equal 0, it may equal minus 3.4, it may equal 10. So it is known as an indeterminate because its value actually depends on how that number came about. And when you go into further maths, up into IG, into AS level and into A level, you will find out a little bit about that. And then in further studies into varsity, if you do maths, you will come across that through your functions. All right. Hopefully, again, no issues with this. Something you should have seen before, not a problem. Just remember, power of 0 equals 1, and watch for your brackets if it's a negative number. What about if we have a positive index? Well, positive index is all the stuff that we know and that we've seen before. So the positive index explains how many of that number are being multiplied together. So 2 to the power of 1 says that we have 1, 2 being multiplied. Well, that's just 2. 2 squared, or 2 to the power of 2, says that you have 2 2's multiplied, being 2 times 2, and that gives an answer of 4. So there are 2 of these base 2's being multiplied. 2 to the power of 3 says that you have 3 2's being multiplied. So it's 2 times 2 times 2, and that equals 8. And you can go all the way up. It doesn't matter how many you have. You can go up to 2 to the power of 10, which is 1024. You can go up to the power of 20. It doesn't matter. All right. So interestingly enough, if you have 2 to the power of 100, there are 30 place values that you would have to be going through. That is how big that number is, which is quite interesting, actually. When looking at the negative index, this may be a little bit different. Again, hopefully you would have seen this stuff, but if you haven't, don't worry. I'm going to go through it now. So the negative index explains that we need to tip the expression. So in other words, tipping is something you would have seen with fractions. So it's something like tip and times. So I know some people teach it as tip and times, some people teach it as keep, change, flip. Some people don't even have a name for it. But the whole point with a negative exponent or index is that the number does not become negative. The negative in the index just shows you that it is in the wrong place. Being if it's in the numerator, it should be in the denominator. If it's in the denominator, it should be in the numerator. So something like 2/3 to the power of -1 means that you actually should be tipping the fraction, meaning both of these numbers are in the wrong position. So the 2 being in the top should be in the bottom, 3 being in the bottom should be in the top, and that is why you come out at 3/2. You take 2/3 and you simply flip it. Something like the number 2 to the power of -1 means you need to tip. Well, 2 is actually 2/1. So when you tip 2/1, you get 1/2, and therefore we see that 2 to the power of -1 is actually a half. So what would 2 to the power of -2 equal? So what would 2 to the power of -2 equal? All right, and the correct answer is indeed a quarter. Whether you worked it out or just assume that it was a popular answer, it is a quarter. Now the question is, why is it a quarter? Well, 2 to the -2 is actually 2 to the -2/1. And because this has a negative exponent, it means that this thing here should not be in my numerator. All right. So because it's no longer or not meant to be in my numerator, I need to take it down to the bottom, which means it's actually 1/2 to the +2, because as soon as it moves, the sign of my exponent now changes from a negative to a positive. And we know that 2 squared is 4, which makes that a quarter. All right, what is 2 to the -10? And while you're working that out, again, I try and please emphasize that notice a quarter is a positive value. So 2 to the -2 does not give you a negative value. It is just the position because a quarter is positive. All right, so the answer to this is 1/1024. Hopefully you would have realized that I mentioned very, very, very recently that 2 to the power of 10 is 1024. So therefore 2 to the power of minus 10 is 1 over 1024. So if you multiply this, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128, 2 to the 8 is 256, 2 to the 9, there you can see my 9, 2 to the 9 is 512, and 2 to the 10 is 1024. So make sure that when you're multiplying the 2's, you multiply 10 of them together. So this is what I was saying about even if it's minus 2, you still just tip the number. You do not make anything negative. Whatever negative value it is, it just means that it's in the wrong place. All right. So what happens if you multiply two expressions with indices? So you've got 5x squared times 4x cubed. So there are two different parts of this problem. First part is the numbers in the front. Second part is the variables with the indices. So firstly, you need to multiply the numbers. The numbers have nothing to do with the indices, and therefore you simply multiply them. So 5 times 4 is 20. Secondly, we need to multiply the items with the indices, which we know, but the question is, how do we do this? Well, we've got x squared times x cubed. We know that x squared is actually x times x, and x cubed is actually x times x times x. So there are 3 x's here because the index is a 3, and 2 x's here because the index is a 2. So when you multiply them together, it's x times x times x times x times x, which means that we can see that there are actually 5 x's in total. So it's x to the 5. So therefore, we can clearly see that the answer to this is going to be 20x to the 5. But that was quite a bit of a calculation there. So maybe there's an easier way, instead of having to break down every time we have a variable, break it down and then work it that way. Well, the good news is that we can actually make a rule from this. So if you multiply with the same base, being x here and x here, or a y and a y, or a z and a z, or a whatever, even if it's a number, that's fine, but they have to be the same. Then you just write down the base and you add the indices. So notice 2 plus 3 gives me 5. You'll probably see it in textbooks saying something like a to the power of m times a to the power of n is a to the power of m plus n. This a represents my base. It could be an a, it could be an x, it could be a number, it could be whatever it is. The important thing is that this base and this base are the same. And in your answer, you keep the same base. You do not multiply these bases. We don't multiply them because we see that we are combining it as one item with a common base. Then we add them because you're putting them together, and that is how you come out at an answer.